So if we have a look at this diagram, I'm going to try and point out a problem and then how NAT or network address translation resolves that problem. So we've got a couple of computers on, let's say, a home network connected to an NAT router, which is then going to access a server. So let's imagine we were trying to access a website, for instance, that's held on this server. So we're going to imagine that the top of the two computers, so the one which has got the point 0.2 address, is trying to access this. So in the bottom corner, we've got our the packet of data, or simplified version of that packet of data, where we've got a sender's IP address and the port that's been generated for that. So the client port for that, which we're just going to say is 6,000 at the moment. And then we've got destination IP address and port as well. So a couple of sockets there. What we don't want to do though is, or what we can't do in fact, is use that private address to send or and to receive that data. It's non-routable, so we wouldn't be able to then receive the data back to that address. So what the router is going to do is it's going to change that packet a little bit, and it's going to say, well, okay, I'm not going to use that private non-routable address in there, so I'm just going to replace it with my public routable address. So our packet would then look like that one in the middle, where the sender's address is changed to the router's routable address. Now that's great because when the server receives it, it's going to deal with that request and it's then going to send the data back to where it came from, so the sender's address. The problem, therefore, or the problem becomes that when the router then receives that information from the server, so it's going, right, fine, here's the data for the website you wanted. It doesn't know where to then send it on. Does it send it to the first computer on this network, so 0.2, or does it send it to the other one, 0.3? And this is where network address translation comes in and tries to solve this problem. So what we do, or what a network address translating router has in it, is something called a translation table. And this is quite a simplified kind of idea of how this works. If you look at other examples, they've probably got more kind of fields in there in terms of what's going on. But what I'm going to do is just break it down into the private socket, an NAT port, and then the public socket. Okay, so what would happen is this, where our sending machine, so the one that wants this data, so point 0.2 machine, would then send its original packet of data to the router. The router is then going to do the same thing, in fact. It's going to change that packet of data to have its own address in there. But what it's going to do as well is it's going to store some information in this translation table. So it's going to store the original address that was on that router. So it's going to keep the address of that computer that's originally sent it and the port and the socket for that. It's also going to create its own port for this. So we're just going to say 8,000. Okay. It's then going to create a public socket. So the public address, IP address with that new NAT port on there. And it's going to use that to put on the packet of data that's being sent. So the sender's IP address and port is now going to be 42.8.1.5 and 8,000 being the port. It's going to send that off. The server's going to deal with it and send data back to the router using that routable address that we've got. The router is then going to receive that and it's just going to look up in its translation table. It's going to go, right, well, on that port was this original private socket. So what it can then do is replace the destination address on the packet that's come back to it with the original sender. And therefore it knows where to send that data within that local network.